we're going to look at adding 3 vectors, all at different angles. So first thing you do when you come across a question like this is, first of all, you got to realize you need a lot of paper, a lot of space, okay? Because we're just going to keep redrawing it and breaking it down and breaking it down. The other thing to do is to start off with a rough sketch of it at the beginning. The 3 forces are 20 newtons at 0 degrees, 15 newtons at 130 degrees, and 10 newtons at 250 degrees. So this will look something like that. 0 degrees, 90 degrees, 180 degrees, 270 degrees. Let's put our forces in. The first force is 20 newtons. We'll put that up here. 20 newtons at 0 degrees. Down here at 130 degrees, roughly down here, where's 15 newtons. It's not going to be quite as long. And the last force is at 250 degrees, so it's going to be out here somewhere. It's going to be 10 newtons, half as long as the 20 newtons. Just a rough sketch. From that, we can guess where our answer is going to be, because the guessing is quite an important process. So we can take this 15 newtons and we can transfer it. We can add it onto the 20 newtons, and then we can add the 10 newtons onto it. So let's do that. There's our 15 newtons. Added that on there. Add our 10 newtons. And that gives us our answer, sitting in the middle there. Doesn't matter which order you add them in, because we could have started here at the 15 newtons, added the 20 newtons on, then the 10, it would have taken to the same point. Or even over here, we could have started at the 10, added the 20, and put the 15 on. Could have gone the 10, the 15, and then added the 20. So still all wind up at the same point, adding 3 vectors. That's the first process as a guess, because we're going to look at that guess at the end. Make sure we're in the right quadrant, got our angles right. So the answer we're after is this piece of vector here, and the angle, of course, we need to return with an angle. To solve this, we approach it like the other vectors that aren't at right angles, and that's what we turn it into right angles for ourselves. So we can put the 20 newtons back in. We'll redraw it, 20 newtons, and what we're really interested in is not this 15 newtons here or this 10 newtons here, but we're really interested in the elements that make it up. So we form some right angles here, like that, right angles here, and we want the value of these 4 new vectors here. And we can use that using our right angle triangle rules. This is 15 newtons here. That's our angle there. We were out here at 90 degrees, and this vector's at 130 degrees. That angle in there is going to have to be 130 minus 90, so that gives us 40 degrees. This one on the other side here will be 270 degrees minus the 250 degrees, and that one there will be 20 degrees. If we know the angles and the lengths, we know that angle, that length, we can work out these two sides. First thing we do is we label our triangle opposite the angle, adjacent, hypotenuse, opposite, adjacent, hypotenuse. Redraw that to make it a bit clearer, and then we'll have a look at these. So there's our opposite, our adjacent, and over on this side, same thing, opposite and adjacent. We'll call these A2 and O2, so that we've got our O, a O2 and A2. Our adjacent, if we look at our triangles, we'll just look at these two, so, ka, and we won't worry about the toe for now. Okay, if we look at these two triangles, the sine is equal to the opposite over the hypotenuse. So if we want to find the opposite will equal sine 40 degrees times the hypotenuse, and our adjacent here will equal the cos of 40 degrees times the hypotenuse. Same over here. This one here is going to be cos 10 degrees times hypotenuse, and that one's going to be sine 10 degrees times hypotenuse. Let's put them in our calculator and get an answer. This one here, 11.49 newtons. This one here is 9.64 newtons. And over here, I'll put these answers out this side. We've got 9.39 newtons and 3.42 newtons. So we can redraw this just using the new elements, and it'll look like this. I'll draw this in black. We'll have 20 newtons there, 11.49 newtons there, coming down here 9.64 newtons, coming out here we have 9.39 newtons, and coming back down 3.42 newtons. All these forces are just on the two dimensions now in opposite directions, and we can start cancelling them out. This 11.49, we can take the 9.39 off, and we wind up with 11.49 minus 9.39, and they'll return a force of 2.1 newtons going that way. Likewise, this 20 newtons going up has 9.64 going down and 3.42 going down. So we can say 20 newtons minus 9.64 plus 3.42 equals 6.94 newtons, still going up. We can redraw this, and what we wind up with is 2.1 newtons and 6.94 newtons, giving us our answer. Turn that into a right angle triangle. There's our answer in red, and there's the angle we require. You can go ahead and solve that because you know how to do two vectors at right angles. But what we will do is we'll go back up here and we'll compare that 2.1 to 6.94, and I'd say if you came out about 2.1 and up about 6.94, it's looking pretty good. So we're definitely in the right answer range.